we want to simplify these radical forms. We have two layers of radical sign here. I have an index 3, we have index 2 by default. So simplify this means we only left with one layer of radical signs. So how to do this? Well, first let's call this some variables. Maybe call this, anything, x, y, or mn. Let's call this m. Then we want to use it's something like conjugate, right? Like square root 5 minus 2. And maybe we'll call this n. We'll call this n. Then if we raise n by 3, we get a square root 5 plus 2. If we raise n by 3, we get a square root 5 minus 2. So if we subtract m cubed minus n cubed, right? Cube, we can read as m raised by 3 or m cubed, n raised by 3 or n cubed. Then what do we get? We get square root 5 minus square root 5, that's 0. Got 2 minus negative 2, become 2 plus 2, so we get a 4. Right? And if we multiply these two, let's multiply m and n. Because both and the cubic root, so we see we have multiply these two conjugates. So we get square root of 5 squared minus 2 squared, which we get cubic root of 5 minus 4, which is as 1. Well, cubic root of 1 is still 1. So we have this beautiful relationship. M times n is 1. Now, the cube, we can factor, difference of two cubes, we can factor as m minus n times m squared plus or minus plus mn, then plus n squared, that equals to 4. Okay, and then right, so we have this relation. Now m minus n, so let's rewrite this one. Let's rewrite this relation. So if we want to write this as m minus n squared, so we can write as m minus n squared, then we would have, because we have 1 plus 1mn, we need to subtract. We need a plus, because here we get negative 2mn. So we need to add 3mn to offset with the negative 2mn from the perfect square. Right, so we rewrite this expression as this, because we want to make a relation with this m minus n. So that equals to 4. Now let's substitute. Let's use one variable to substitute m minus n. So if we call m minus n some number k, then we can write this as k times k squared plus, remember m times n is 1. So m times n is 1. 3 times 1 is 3. Then minus 4 equals to 0. So we can rewrite this as k cubed plus 3k minus 4 equals to 0. And this one, if we use rational root theorem, this one can be factored. So let's write over here. So we can factor this by rational root theorem. We can factor as k minus 1, then k squared plus k plus 4. That equals 0, right? You see we have negative k squared here. Multiply these two, get negative 2 squared. Multiply these two, get a positive k squared. They cancel each other, right? So the k squared term cancel each other. Okay, now k squared plus k plus 4 in real number system, this has to be greater than 0, right? It won't be 0. You can use completing squares to verify that. So that means using 0 property, that means k minus 1 has to be 0, which means k equals to 1. Remember what's k? K is m minus n. So that means m minus n is 1. Now this gives us a relation because we call this expression m, right? So let's substitute n. So we rewrite this equation as n, move negative n to the right hand side, positive n, move 1 to the left hand side becomes negative. So n equals m minus 1. We want to use this relation. Right, we have m times n, we use this, m minus 1, that equals to 1, right? M times n equals to 1. So that gives us m squared minus n minus 1 to be 0. Or use a quadratic formula, right? Solve quadratic equation. So m equals to, right, negative 1, 1 plus minus square root of b squared negative 1 squared is 1 minus 4ac, 4 times negative 1. Then divided by 2 times a, which is 1. So what do we get? We get 1 plus minus square root of 5 divided by 2. Right, that's by solving this quadratic equation. But if we go back, we see m is a positive number. Right, m is a positive number. So we cannot take 1 minus the square root of 5. Because square root of 5 is a 2 point something. 1 minus 2 point something would be negative. So we reject the negative sign. You see, m equals to 1 plus square root of 5 divided by 2. Okay, so by doing this, by using this algebra, the formulas, and we reduce this expression. That's why algebra, formulas are so useful. So this one can be simplified to be 1 plus square root of 5 over 2.